Hey everybody, Mr. Piercy here, and what we're going to be talking about today is getting into similarity, proportions, and something known as geometric mean. So this topic that we're going to be looking at when we're looking at similarity, you're going to see a lot of things that are going to be recurring, and this first lesson is basically just making sure that can you set up and solve a proportion? Because if you can, then most of the rest of the things that we'll be doing in this unit will not be all that challenging. So here we have some vocabulary terms, and really three of the four of them are somewhat important. So first of all, a ratio is basically when I'm just comparing two things together. And whether they're similar things or dissimilar things, it's just we're comparing two things together. I have three of these and two of these. Whether it's length to width, uh, maybe perimeter to perimeter, something like that. We're just comparing two different things. A proportion is when I take two separate ratios and I put them in an equation. So I say one ratio equals another ratio. That's called a proportion. Now the third one means in extremes. That one's not going to be something that we're going to spend a whole lot of time talking about. You don't really need to, I'm not going to ask you to identify, is this a mean or is this an extreme? I'm not going to identify that or ask you to do that. But just understand that they are what they are. B and C in this particular ratio are the means, and A and D are what we would consider the extremes. Now, the last one is geometric mean. This is something that we will be coming back to at some point in the future, but geometric mean is another way of finding a value of something that's a little bit different than an arithmetic mean. An arithmetic mean, let's say I have 2 and 5 and 8. And what you would do for an arithmetic mean is you would say 2 plus 5 plus 8, and you would divide that by the number of numbers that you're adding. So in this case, you would divide by 3. So here we would have an arithmetic mean of, let's see, 15 over 3, 5. Now the geometric mean is a different type of mean than an arithmetic mean. What it is we're going to be taking the products of things, and to find the actual geometric mean is I'm going to take the root of however many products that I have. So for instance here, the geometric mean, and we'll explain this in a little bit further detail, we're going to say x times x, which will give me x squared, times is equal to a times b. So we're going to say x, the geometric mean, is equal to the square root of a times b. Now that's going to change a little bit depending on how many values that you're actually taking the product of. And I'll explain that a little bit further detail later on in the lesson. But for now, pretty much geometric mean is really going to be for you guys just that little bit right there. So here, the first thing we're going to be taking a look at is, can you simplify a ratio? Now, a ratio in its most basic form is really just a fraction, and you can simplify a fraction by identifying the greatest common factor between the numerator and the denominator and simplifying it and see what it is. So that's all this is asking us to do, and most of us will be able to use our calculators to simplify the ratios for us, which is fine. As long as you give me a simplified ratio for an answer, that's all that really matters. If you give me a ratio that can be simplified, but you don't, odds are you're going to lose some points for not simplifying your ratio. So here we're going to take a look at the ratio of 76 centimeters to 8 centimeters, and well, 76 over 8, certainly they're both even numbers, so they definitely can simplify. In this case, they simplify to be 9 over 2, or 9 to 2 if we use the colon symbol instead. So 4 feet to 24 inches, this is something that you might want to pay attention to. Here, it looks at the outset that you'd want to take this fraction and simplify it to be like, say, 1/6. But pay attention to the units. We're comparing feet to inches. So we want to convert either feet to inches or inches to feet before we actually do the conversion. So here we're going to convert the feet into inches by multiplying 4 feet by 12 inches, which gives me 48 inches to 24 inches, which gives me a ratio of 2 to 1. So here, this is a really good example of how we can use ratios in a type of problem that we're going to be looking at. Here we have the ratio of the length to height of a barn door to be 3 to 5. So if you're thinking of a barn door, you say, well, it kind of looks like a rectangle where this is 3 somethings and this is 5 somethings. So we're going to compare the ratio, the length and the height. We're going to call the length 3x and the height 5x. Now, the formula that we have to find the perimeter of a rectangle is just 2 times the length plus 2 times the width, because I have 2 lengths and 2 widths in a rectangle. Well, substituting 3x for the length and 5x for the width gives us the equation 2 times 3x plus 2 times 5x. Now, when we simplify, when we multiply and combine our like terms, we get 16x is equal to 64. Divide both sides by 16, and we get x to be 4. So now that I know that the value of x is 4, I can find the values of the length and the width respectively by substituting the 4 in for x. So we get the length of the barn door to be 12 feet and the height of the barn door to be 20 feet. Oh, and the area. Area is length times width, so we could say 240 feet squared. Now, interestingly, we could have set up this problem without having to do perimeter. If I said area is equal to length times width, I could have easily simply have said, well, if we knew the area in advance, we could work it out. So I could say 3x for the length times 5x for the height, which would have given me 15x squared. And if we knew the area, then we could divide by 15 and then take the square root of x, but we didn't know the area. But that's how we would have done it if we did. So at this point here, guys, go ahead and pause the video, answer these 3 questions, simplify the ratios, and basically do the perimeter problem one more time. Find the length and width of the table. And when you have your answers, go ahead and hit play and come back and see how you did against compared to my answers. Okay, so hopefully you've achieved your goal. The first one, we're just simplifying the ratio. We're going to say 4 meters to 18 meters. When I simplify that one, I'm going to get either 2 to 9 if I wrote it as a, with a colon, or 2 over 9 as a fraction. On the next one, again, we're going to kind of compare 33 yards to so many feet. It's 9 feet. So how many yards are in a feet? This one is not quite as well known as the fact that there's 12 inches in a foot, but there's 3 feet in 1 yard. So that basically gives me 99 feet compared to 9 feet, and 99 compared to 9 as a ratio simplifies to be 11 to 1. And finally, for the perimeter, for the length and width here of the table, using the same method that we did a second ago, I'm going to say take the perimeter formula, and since we know the perimeter, 2 times length plus 2 times the width, and substitute 5x for the length and 2x for the width. Solve for x, and we get the length, or x, to be 1.5. So substituting the 1.5 in for length and width gives us a length of 7.5 feet and a width of 3 feet. Here, the ratio problem that we're kind of seeing here, this is very similar as an extension to the perimeter problem that we just saw. And we've actually seen problems like this before where we say the ratio of the 3 angles, in this case of a triangle, are something compared to something compared to something. In this case, 2 to 3 to 4. Well, the 3 angles, 2x plus 3x plus 4x, they have to add up to be 180 degrees. So, and we've seen problems like this in the past in other assignments. We just didn't think of them, or we just didn't approach them in the terms of a ratio of, well, whatever this one is 3 times and this one is 4 times or whatever. But same idea, solve for x in this case, and we get 20. So the measures of the individual angles, 40, 60, and 80 degrees. So here, go ahead and take a moment, same exact question, just with a different ratio, and find the measures of the angles. So go ahead and pause the video, work out checkpoint question 4, and when you're done, hit play again. Okay, so hopefully you set up your problem and found the value of x to be 18. So the measure of the 3 angles, we would say 18, 72, and 90 degrees. So this is where I would, in another way of phrasing a problem like this, I would say, like say angle A is something, or so I might say that angle B is 4 times angle A, and angle C is 5 times angle A, so I call angle A x, angle B 4x, and angle C 5x, and then go from there solving for x. Now here, this is a little bit of a pet peeve of mine. When you're solving a proportion, because that's what we're getting ready to start doing, we're going to start solving proportions. We're going to start solving proportions using cross products. We cross multiply and divide. Let's see, if I have A over B is equal to C over D, like they're giving us an example, depending on what you might have seen in prior math classes, your math teacher probably circled the things that were going to be multiplied together, and then I don't know, they called that the butterfly method because it kind of looks like a butterfly when you circle the things that get multiplied together. I will not be referring to it as the butterfly method at this level of math. I really think that you guys should know what things are called and therefore call them by whatever they're supposed to be called. So here we're doing cross multiplication. And that's essentially what it's telling you to do here. Now pay attention. This isn't going to be something that we're not going to see a whole lot of. But of course the denominator of the ratio can't be 0, because if I try to divide by 0, that gives me something that's undefined. So that's all we're kind of looking at here. We're going to do our cross multiplication and find different values. Now because the ratios have to be the same in a proportion, whatever is on the left side of the equal sign and whatever's on the right side of the equal sign, they have to be the same thing. So if I take that 4 over 6 and I simplify it, I will get the 2/3, which essentially, again, the idea of an equation, everything is balanced on the left side to the right side. So here in example 4, part A, this is a very typical kind of problem that you're going to be working out, where you're going to say, find the missing side of a figure, and you're going to set it up using cross multiplication, where you set up a proportion with 2 ratios. So taking what we have here, we're going to take, usually I take the numerator on the left side and multiply it to the denominator on the right side, and then I take the numerator on the right side, multiply it to the denominator on the left side. So they have it set up pretty much how I would do it here. We were going to say 3 times 16 and 4 times x, and then simplify your values. So we get 48 is equal to 4x. Divide both sides by 4, and in this case we get x equals 12. Now example B is going to look a little bit different than what you might be used to seeing. Here we're saying 3 over x plus 1 is equal to 2 over x. Well, it's still a proportion. We're still saying that the ratio on the left is equal to the ratio on the right, and we're still going to cross multiply. So I'm going to say 3 times x on the left and 2 times the expression x plus 1. Now pay attention that they're keeping the expression x plus 1 in parentheses, because we're going to use our property of distribution here, and we're going to have to multiply the 2 to the entire expression. It's not just 2 times x. So on the left side we just get 3x, but on the right side when I distribute the 2, I get 2x plus 2. Move the 2x from the right side to the left side, and in this case x is equal to 2. Now, one additional thing that you guys are going to see that does have a tendency to throw students off sometimes. Let's say we have 4 over x is equal to x over 9. Well, when you cross multiply here, I'm going to get 36 to equal x squared. And that seems to throw a lot of students off sometimes. Sometimes they'll say 2x, they'll add instead of multiply. Or even if they get x squared, they're not sure what to do at this point. Well, at this point here, because we have x squared, the way that we undo a square is with a square root. So in this case, I could say x is equal to 6. I might even say positive or negative 6, depending on the situation that we're in. But that's how we would set up a problem like that when the x's get multiplied to each other. So here we're taking a look at an application problem of how we're going to use ratios to set up and solve a proportion. Now, here they're setting it up in terms of a bowling alley, and we want to know, well, how many find the total number of rows of boards that it makes to make up 24 lanes. Now, whenever you're setting up a ratio or a proportion, pay attention to how you set it up. So here we have the number of rows compared to the number of lanes. Now, that's not the only way that you could set it up. I could very much say the number of lanes compared to the number of rows. It's just that however I set up my first ratio, the second ratio has to be set up using the corresponding values or the corresponding parts. So in this particular example, we could have very easily had said 3 over 117 is equal to 24 over n. It doesn't really matter because we're still multiplying the same values and we're going to divide by the same value. So here when we cross multiply and solve for n, the number of rows that we're going to have, we get 936 rows. Just keep in mind, whatever I put in the numerator of my first ratio, I have to have the same value or the same corresponding side or the same something when I compare it in the second ratio. Turn the page. Okay. So here is geometric mean. This is where I told you at the beginning of the lesson that we were going to get into this in a little bit more detail. Geometric mean, what we see in the box, what you have in your notes, is very typical of what we will be doing in geometry for geometric mean. The thing that I have here in the box, the black background, application of a geometric mean, the main thing that we will actually use it for in geometry is to find the altitude of a right triangle from a right angle. Because if I have a right triangle, so we have this great big yellow right triangle, and we have the altitude being drawn in here. Well, the two sides that get broken up by the altitude are proportional to each other, and we can use them to find the geometric mean to find the actual altitude here. We're not going to do that right now, but we will be doing that in the future. What I have here is a more appropriate definition of what the geometric mean is. So in the example in the box we have x is equal to the square root of a times b. Well, I'm taking the square root because I'm multiplying two values together. I can do the geometric mean with more than that. Say I multiply three values together. Let's say a times b times c. Well, I would take the cube root of that because I'm multiplying three values together. If I had four values together, a, b, c, d, I would take the fourth root. So that's how the geometric mean actually works. And the part that we see here on the left, I'm particularly looking at this. If I say the square root of x, that's the same thing as saying x to the 1/2 power. Whatever my index number is and whatever the exponent inside here is, that's kind of how they do that. We're not going to do that in this class, but again, I think you guys should be aware of what it is and where it comes from. You'll be looking at properties of exponents and how you convert them into radicals much more in Algebra 2. Now this extra addition thing here that I provided, don't even think about copying it down, just read over it. This is an application of how geometric mean is used. Here in the idea, or in this example, we're talking about interest rates, which is something that people look at very much all the time. If you have anything dealing with money, you're probably, if you're investing something or if you borrowed something, there's very much interest rates associated with that. So in this example, they have an investment which earns 10% the first year, 60% the second year, and 20% the third year. And we want to know what's the average rate of return. Well, that keyword right there, average, is going to throw some people off. It's not the arithmetic mean, where I'm not going to say this number plus this number plus this number divided by 3. Because these are interest rates, these numbers are multiplied together and not added to each other. So that means if I want to know the average rate of return, I have to use the geometric mean, which is right here, where I'm taking the cube root of the 3 values. So it's very useful outside of geometry. It's something that we can use on the real world, so to speak. But for the time being, for us, all we're really going to be using it for is, right now, can you actually do it? Can you just do the geometric mean? And what we're going to be looking at is really just 2 values. We won't go beyond that. That's why we'll say the square root all the time. So if I want to know the geometric mean between these numbers, well, the geometric mean is the square root of the 2 values multiplied together. So in this case, 16 times 48 gives me the square root of 768. And when I simplify the radical, I get 16 radical 3. Now, if your calculator is set up to simplify the radical for you, that's great. If not, I kind of have it here on the side as showing how we're breaking it down to show how we simplify it. Basically, when I simplify a radical that's a square root, I want to find the largest perfect square number. Well, the largest perfect square number of 768 is number 256. And the square root of 256 gives me the 16 with remainder radical 3. So here we are at the end. Go ahead and pause the video and work out these 4 examples. And then when you're done, come back and compare your answers to mine. All right, guys, I'm hoping that we're all ready to go now. You've hit play, now you're ready to compare your answers. So on 5 and 6, let's just do some cross multiplication. Find the value of y on problem 5, find the value of x in problem 6, and we get 20 and 9 respectively. So here we're comparing the number of seats, or the number of sets of bleachers for the number of spectators. So however you set up your ratio, whether you say spectators to bleachers or bleachers to spectators, in this case, when we set it up and solve for x, I get 640 spectators in this particular example. And then find the geometric mean of 14 and 16. Well, here, multiply the 14 and 16 together and take the square root of it, and we're going to get 4 radical 4 is the exact value. Or if we wrote it as a decimal value, we would round it to 3 decimal places, and I would say x is approximately equal to 14.967. So that's pretty much it for this lesson. The main thing being, can you set up and solve can you simplify a ratio? Can you use 2 ratios to set up and solve a proportion? And can you find the geometric mean between 2 values? But that's it for today's lesson. And if you have any questions, as always, make sure you send me a comment, send me an email, leave me something in the Google Classroom if you're not sure about anything. And until next time, guys, thanks for watching and take care.